this tutorial we will see how to pair Brainsight with the Cobot. Start by creating a new MNI head project. Go straight to defining my targets. I will define M1. With a new trajectory, because the Cobot needs a trajectory to define the point of stimulation. Call it M1 for instance. Then I go at the level of the dorsolateral prefrontal cortex approximately, and I create a new trajectory. And I can do this so on and so on. What I want to do as well is to create a new rectangular grid, and by using this cursor I can move the grid at the level of the motor area. I can deactivate this command, and here select the characteristic of the grid. So the name, M1 mapping, color for instance, the kind, I want a trajectory as I said. I can change the grid size, the grid spacing, and so on, and see here the result. As you can see, the grid is flat, the brain is curvilinear, so we need to adjust this by clicking on snap to and snap to the curvilinear brain. So this way the points nicely match with the shape of the brain. Close it. This point, very important, is to save what I did until now, because sometimes the system freezes with the next step, and then we need to restart, shut down, restart completely the program, and if we don't save we lose all the data, all the work that we did until now. So start a session, new online session. We can drag all the targets that we need on the right side here, even more than once if we want. Here, for instance, we dragged all the target for the M1 mapping. Here are reported in order, but we can also randomize them. Then we go to next step. Here is for connecting the EMG registration. And we go to next step. Here's the Polaris view from the top, from the side, from the front. Important is that both the assigned column Cobot on the right side and the subject tracker are visible. We are using the setting on the right side because we want to stimulate the left side. So next step, here nicely visible. So we go to the next step, which is registration of the landmark in correspondence, in this case, of the phantom head. So for instance, I needed to do in a way that both on the bottom left that the pointer and the subject tracker are visible, and then okay.
Bär.
Next step is scaling. So for scaling, we take several reference points. We don't need to do this if we already have an MRI scan. Okay. So once we are done with this, we go to the next step, which is actually connecting the Axylum Cobot with the in this step we are going to connect the Axylum Cobot with Brainsight. So we start. With a moment that we see here not calibrated. Here we click for calibration. This sounds means that the brakes are off, and we go for the force sensor test. Force sensor test consists on pressing progressively the platform here and depressing until we see that all the flags here are green. Then we click on finish. Then we can go in park position. It means that the robot moved in the average park position. From this point, it is important to set the patient exactly underneath the parking position. So we want to put this side underneath the coil. And a distance between 5 and 10 centimeters between the coil and the target. At this moment, the targets are not projected, so we need to click on project targets. Then with the green flag, it means that the targets are reachable. We can check how the coil will work by clicking on move and follow. So for instance, if we select M1 and we click on move and follow, the coil will go in correspondence to M1. Then if we want to check dorsolateral prefrontal cortex, click on move and follow, and the coil will move accordingly. If you want to let the coil leave the contact with the subject head, we click on contact off, and the coil will distance. We can also check for the mapping that all the points are reachable. All the points are reachable, as in this case. So we go to next step. Receive this message. We just change here from pointer to Axylum arm. Okay. So let's say that we want simply to stimulate at the level of M1. So we select it here, and then we go to move and follow. And as we saw previously, the coil is moving towards the target. And here we can see, and here, the movement and the amount of precision. And then here we can start with the stimulation. The same if we want to go to the dorsolateral prefrontal cortex, we simply ask move and follow, and the robot will execute. Okay. If you want to do the mapping, finally, we are selecting here all the points. We select the first one here, and when we go on start mapping, the coil will start to go in correspondence to each point. Here we can see that the number of pulses and the pulse interval is set by default to 3 pulses and 3 seconds of interval between each pulse. This is the number of stimulation that will be applied on each point. At this point, the system cannot automatically control the stimulator. We have actually to do it manually, so by pressing a button. What Brainsight will do is to display a window here to trigger the stimulation. So when we see the window turning from black to white, it means that we have to push the button for the stimulation. So so here I can activate and put the amplitude that I wish. Each time I press this button, the stimulus is delivered. So so I'm ready with the finger at the level of the button, and I want to do the M1 mapping. So I click on start mapping, and this is the visual trigger that I have. So each time will become a white, I will push the button. As soon as the coil is ready, I will see the visual trigger. So now we did already 1 point. The coil is moving already to the next one. So this is what is happening. Now, for instance, it's moving to the next target. And now to the next one. And so on. If at any point I want to stop, I just pause the mapping, and the coil will automatically go off contact. When I'm done with the stimulation, I just click on finish. When I'm done with the stimulation, I just go back to the axylum and click on stop. This will disconnect the Cobot from the Brainsight. At this point, I manually I can put the manual mode to remove the coil from the subject. And then the session is ended.